As we saw in the previous videos, a buffer solution works best when the ratio of the conjugate base to the conjugate acid is equal to 1. And so when that is the case, our buffer solution will be able to resist the changes by the addition of strong acid or strong base equally. And so if that ratio is 1, then the pH will equal the pKa. And so when we're asked to prepare a buffer solution of a particular pH, it is important to choose a reagent where the pKa is close to the buffering pH that we want. And that way we will have to only adjust the ratio of conjugate acid and base slightly. So in this case, we're asked to prepare a buffer solution of pH 5. So we want to look on our Ka chart and find an acid, a weak acid, where the pKa is close to 5. Okay, and so in this example, acetic acid will be sufficient. Acetic acid has a Ka of 1.8 times 10 to the negative 5 and a pKa of 4.74. And so what we're going to do is we're going to use the Henderson-Hasselbalch equation to determine the ratio of conjugate base to conjugate acid that we would need to adjust the pKa from 4.74 so that we would have a pH of 5. So I'm going to say that my pH is 5, my pKa is 4.74, plus the log, and in this case the conjugate base is acetate ion and my conjugate acid is acetic acid. Okay, and so then we're going to say that the log of this ratio, again the log of the acetate ion over the acetic acid concentration, that's equal to 0.26. Okay, so in order to solve for this ratio, we're going to change in log form into the power form. So this ratio should be equal to 10 to the power of 0.26. Okay, so a reminder here that if I have log base 10 of x equaling y, then that says that 10 to the y should equal x when I change form. So that's how I'm doing that there. Okay, and so that means that ratio is equal to about 1.8. And now there's lots of ways to achieve a ratio of 1.8, and since the question doesn't specify anything about buffering capacity, we could choose any values we'd want. Okay, so we'd want to have, say for example, 1.8 molar sodium acetate and 1.0 molar acetic acid, and that would generate that ratio for us, and we could use any combination of numbers that would produce that ratio. The larger the concentrations, the larger the buffering capacity would be, but they would all buffer at the same pH of 5 because that ratio would still be the same regardless of their concentrations. So for example, I could also do 0.18 molar sodium acetate and 0.10 molar acetic acid, and this would have the same ratio of 1.8, so I would buffer at the correct pH. However, this second buffer would have a lower capacity.